Okay, today we're going to start our unit on quadratics. I told you that was the next topic, so you're going to learn everything you wanted to know about parabolas. All right, we have graphed a few of these already. I'm going to start with C. Why? Well, because it's the parent graph. And I just thought, what the heck, let's look at the most basic parabola. Okay, and that's when, and these are going to be right now in the form y equals a times x to the second. And then we'll do other transformations to it. So what we're looking at right now is what does the a value do to the graph? And we've already discussed it on other graphs. So you might actually have some insight into what's going to happen. So we go to our graphing calculator, and in our first line put x squared, because that's 1x squared. You don't have to put the 1 in, but of course it would be okay if you typed it in. And then we have a look at it. Oh, I'd like everyone to do the same thing so everybody's looks the same. So if you would hit the zoom button and then hit 6 so that we all have the standard window. And it will graph that parabola for you. Okay, so this is your basic parabola. It has symmetry. See this? There's two sides that are equal. The y-axis is cutting that parabola in half. So you can go to the table, hit second, and graph. And the table will be there with point values in it, which you can scroll up and down using your toggle switch on the right-hand side of your calculator. So what I wanted to point out is, let's go look at I want you to see some of the symmetry numbers. You see the 0, 0? That's where this parabola's vertex is. It's its lowest point. All right, and then there's negative 1, 1 and 1, 1, negative 2, 4 and 2, 4 on the graph. So let's go back now and graph the parent. So the graph, was that a blue graph? I forgot what it looked like. It doesn't matter what color. Anyway, first point we had 1, 1. We had negative 1, 1. We had 2, 4. And we had negative 2, 4. And this is your normal width parabola. This one we would describe as normal. It has that's the normal width because the a value is 1. All right, now we're going to go a little faster. We're going to put in the first one. Let's go to A. We're going to put in 0.25. We're going to keep all the graphs on one calculator screen. So we'll go to y equals, go to line 2, so just arrow down, 0.25 x squared. You use the X button up here next to the alpha key. Hit your squared button, press graph. Okay, so what did that 0.25 do? Made the graph wider. If I do second graph, I can get some numbers out of my table again. And I can see that negative 416, which I'm not going to be able to plot that, negative 39, negative 24. Uh-oh, no, I'm reading the wrong ones. Which one should I be reading? The y values that are in the y column. So negative 4, 4 will plot, negative 2, 1, etc. So if it's negative 4, 4, and I'll show you a really fast way for you to graph it. Once you know 1, 1, 2, 3, 4, negative 4, 1, 2, 3, 4. If negative 4, 4 is on there, then what other points on there? 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. Okay, because they're going to have symmetry points here. This thing still had a vertex of 0, 0. Was there another nice one that was in the list? No, the rest of them, oh yeah, negative 2, 1. Bless you. And then 2, 1. So it widened the parabola from normal. So this would be wider, if you will. The 0.25 stands for an a value of 1/4. Now here, it's 0.5 for the a value, which is actually negative. So what do you think that negative might do? Instead of opening this way, it's gonna, yeah, so this one's gonna flip over the A value is -1/2. So it reflects and flips, and that 1/2 is going to make it wider also than the normal parabola. So let's go into our grapher, -0.5 on the line y3. So we'll just arrow down here, put in -0.5, which is 1/2 x squared. And that's exactly what happened. It flipped it over. It is still a little bit wider than the red one. I mean, it's not as wide as the red one, but it's wider than the original blue one. Okay, so you can get some points again in your table if you want. Or we could just put some numbers in, but there's the black ones up here. I've got -2, -2, 0, 0, 2, -2. Oh, I should go to black. And 3 points is all I need for your accuracy. And make sure it looks like a U, okay, not a V. All right, so what do you think 2 is going to do? I think it's going to make it, well, the fractions made it wider, and this one's got an A value of 2. It's going to get narrower or skinnier. That's another way to say it. I heard someone say skinnier. Let's go to line 4 and then the 2x squared. Okay, and then graph. And sure enough, it's skinnier than the original blue one, the first one we did. So I can go to the table. This is going up. The y's are getting bigger faster. That would be, oh geez, big points. I got -1, 2, 0, 0, and 1, 2. And then -3 is going to make it skinny, and I think I'm going to not going to graph it on the grapher. I'm just going to say it's going to still have a vertex at 0, 0. It's going to flip down. If you put in 1, 1 squared is 1, you'd get -3. And the matching point on the left would be at -1, -3. Okay, and this one had an A of -3. We're good? No? What do you need for did you not have trouble putting them in? Did we have trouble with them graphing simultaneously? The calculator goes a little slower. You certainly may borrow the one in here, but I understand that will be what you have to use at home, right, too? You good? All right. I didn't put the last one. So what was in common of all the graphs? All of them were what shapes are they called? Parabolas. They're all a parabola or a U-graph. Now, again, I wrote the quotations on it because obviously they change shape a little bit and they flip over and they slide around. Under what conditions does the graph open upward? That was when the A value was positive, bigger than 0. And when it opened downward, A was negative, so less than 0. And was the absolute value, now they're saying don't pay attention to the fact that A might be negative. As the absolute value of A increases, it goes up, the graph gets skinnier or narrower. And what's happening is Y grows faster. So the Y values get bigger faster is what I mean by that. All right, we're going to kind of look at this again and look at a different movement on the graph. Okay, so next, I believe I changed on your papers to 2's, right? All of these are 2's now. Okay, so if we go in the graphing calculator, I'm I think we only need to really type in maybe one or two. We're going to go to y equals and clear out the stuff we have in there. Okay, and then by inspection, let's go up to the first line. And the first one was 2x squared plus 4. Okay, I'm going to graph that. What did plus 4 do to the graph? Pushed it up how much? So the vertex moved up 1, 2, 3, 4. Okay. What's the next number? 2. I'm going to go on line, oopsie. Go on line 2 and do 2x squared plus 2. So the first one was up 4, the second one's up 2. Do we have the idea, I think, of what's happening? Okay, so let's go quick sketch all these on one graph. All right, so 0, 1, 2, 3, 4. That was the first one. If you actually put in 1, you would get 6. Do we even have 6 on here? No, so let's just talk about the shape, what's happening. Then the second one was the vertex was shifted up 2. These were all skinnier than the average parabola, but they all have the same width in general. So what do you think minus 2 is going to do? It's going to stay the same shape, but move down 2. So this is just going to do this. Okay, so all I really want to see right now is you understand that the value out here, which would be a K, and that we've been talking about before, but they're calling it C, shifts it up or down. So, what? Oops, what a sloppy mess I made there. Okay. All right, anyway, just shift it. So what is the value of C? How does it affect the graph? It changes the y-intercept. Yes. Okay, ask me that again, please. Mm-hmm. The front number is a positive number, so A is 2 here, so it's going to open up. Yep, there we go. All right, so changes the y-intercept or shifts it up or down. So at what point would the graph of y equals 2x squared minus 8 intersect the y-axis? It would be at 0, -8. And 3x, or I think I changed those to a 2. Y equals 2x squared plus 5 would intersect it at 0, +5. Okay, we've already discussed that K value a lot already, so we probably already knew what was going to happen. What else could happen? Well, we'll be discussing that soon. A parabola has a maximum value when it opens down. That would be because it's going to do this. So this will be your max up here. And it has a minimum value when it opens up. Okay, so your min will be down here at the bottom. It will be the vertex. Are we doing? Can I turn? Yes. Okay, so without using a calculator, we're going to decide what's happening with these graphs that we're about to look at, the equations only. So we have to learn what we want to know what's going to happen without the grapher. So this one will open, since A is -1/4, it's going to open down. It's got a fraction for its width, so it's going to be wide. 1/4, a fraction. So it's going to be wider than the regular graph. intersects the y-axis at the shift up 5 would be giving us a y-axis at 0, 5. And since it opens down, it will have a max. Its vertex would be at 0, 5. So we're going to go to 0, 1, 2, 3, 4, 5. And then I'm thinking, let's put in the number 2 into our grapher. Well, I'm not going to do it in the grapher. I'm going to put a 2 into the equation. So it'll be negative 1/4 times 2 squared plus 5. That's going to give me negative 1/4 times 4, which is negative 1. Negative 1 plus 5 is 4. So we got a point of 2, 4. And then the matching point would be negative 2, 4. What I mean by a matching point is they always have symmetry. So as far away as we are by what splits it in half, there'll be another one. And that's enough, just the 2 points to give us a sketch. Now, you might have thought about putting in 4. That would have been fine too. So if we wanted to get another point, that'd be negative 1/4 times 16, which would be negative 4 plus 5, which is 1. So 4, 1, 1, 2, 3, 4. Wow, I didn't make mine wide enough, did I? I could make it look actually even better by putting in that point. 4, 1, and negative 1, 2, 3, 4, 1. So that thing is really pretty wide. I did that, of course, without a grapher. Let's try another one. This one will open, because A is positive, it will open up. The width will be narrower than a regular parabola, or skinnier. It intersects the y-axis at 0, negative 4. Since it's opening up, it will have a minimum. And the vertex is at 0, negative 4. Okay, putting in 1 and negative 1 will give you the same values. So that's going to be 5 minus 4, which is 1. And then negative 1 would also give you a positive 1. Okay. Anybody still need this page? Fine. Okay, let's try another one. This one has an A value that's negative 1, so it's going to open down. The width will be normal because its absolute value is 1. So what I mean by normal is like it'll have the same width as a regular parent graph parabola, except it's going to be upside down. And it's shifted up 3, so it's intersecting the y-axis at 0, 3. Since it opens down, it has a max point, and its vertex will be at 0, 3. Okay, if I plugged in 1, I'd get 2. Negative 1, I would also get 2. If you wanted to put in 2, I guess I could put this in a little t-chart. 1, 2, negative 1, 2, and if I put in 2, I'd have the opposite of 2 squared plus 3. Remember how we had some trouble with that before about getting the right signs? Some of us did it wrong. When you square the 2, you apply the negative sign after. So that's actually negative 4 plus 3, which is negative 1. And negative 2 would give us the same number, negative 1. So 2, negative 1, and negative 2, negative 1. And then we could get a nice sketch. sometimes you'd want to maybe pick a number that's not right next to the vertex just to get a better feel for the shape. But minimum is 3 accurate points. Anyone need this? Okay, this one's going to open up because it's a positive A value, which is 1/3. The width will be, Scott? Okay, and you were raising your hand. Did you have a question for me? Yeah. I said, yeah, I just can graph. You can always graph more, but you need a minimum of 3. This at 0, -1. And it has since it opens up, it has a minimum. And the vertex is at 0, -1. Okay, so here we go. Yeah, it's opening up. What kind of numbers do you think would be nice to plug in, especially if you didn't have a grapher? You can still get this graphed. 3, yeah, multiples of 3. Good idea, because there's a 1/3 there, multiples of 3. So I would probably just stick in. If you put in 0, of course, you're going to get the -1, which we already got. But if you put in 3, that's going to be 1/3 of 3 squared. 3 squared is 9. So that's going to be 9 minus 1, which is 8. Oh, dear. I can't fit that one on here, can I? Well, can I? Or did I just do that wrong? I did. 1/3 of Miss Heimer. Okay, I was just fairly uncomfortable with my phone ringing. Sorry, guys. Okay, so that'd be 1/3 of 9, which is 3. 3 minus 1 is 2. So 3, 2, and then if 3 2's on there, what's the other one? -3, 2. Now that's not going to work. It's the same when we get to where we're graphing ones that have shifted around, and I'll show you that shortly. Okay, so there's that one. Right. And so let's see, 7. We got an A of -3, so this thing's going to open down. Did I write wider on the last one? Yes, I did. Okay. And this width will be narrower than a regular parabola, or skinnier. Intersects the y-axis is 0, 2, so I think we're getting the pattern here. Since it opens down, it will have a max, and its vertex is at 0, 2. Okay, I think I'm just going to pop in a 1, because those numbers are going to get big quick, or small. -3 times 1 plus 2 would be -1. And -1 plugged in would give me -1 as well. Am I going too fast? No? Okay. Some people think no, I don't know. All right, and the last one we'll look at right here, which is the rest of that page, I believe. This thing will open down because the A is -1/2. It's going to be wider than the regular parabola because it's a fractional A value that is less than 1. It intersects the y-axis at 0, -2, and it has a max. 0, -2 is its vertex. This thing's opening down, so I'm going to put in, 1's not going to be good, so I'll do 2. That'll be half of 4, -1/2 times 4 when I plug it in, and then I have to subtract 2. That's -2 minus 2, which is -4. 2, -4, and -2, -4 then are on the graph. And there it is. Okay, well, that was the end of 1AB, correct? All right, so next we're going to go to 2 and possibly get to something on 3 even. The next two are 2 and 3. All right, so on worksheet 2, yes. because a is a fraction. All right, so when a is between 0 and 1, that's when it gets wider. We're going to be adding that into our notes again a little later as well. If a is bigger than 1, then it's going to get narrower. Okay, it says now write each function in the form f of x equals ax squared plus bx plus c. If you need me, we're going to write that down again a little bit. I'm going to FOIL this out then. Okay, you know that's x squared, and then minus 3x, and then plus 7x, and then minus 21. And then you combine your like terms, x squared plus 4x minus 21. Now, that's not what they're asking though. They want us to identify A, B, and C. So here A would be a 1, B would be a 4, and C would be negative 21. If I multiply the next one out, 2 times x, 2x times x would be 2x squared. I got 1x and 12x, so that's plus 13x, and then 1 times 6 plus 6. See how I'm now doing this without writing all of the steps out? That's kind of an easy way to do it. To FOIL it out, because you know how to do the first and last. Okay. All right, so this would have an A of 2, a B of 13, and a C value of 6. I had tried to explain a way to FOIL this out quickly. What this means, though, is 4x minus 1 times 4x minus 1. So if you need to do it out like that, you can. Otherwise, I'm going to show you the shortcut again. Shortcut says take the first, you do the first times itself. 4x times 4x is 16x squared. 4x times negative 1 is negative 4x, and you double it. So that's negative 8x. And negative 1 times negative 1 is plus 1. So here the A value is 16, the B value is negative 8, and the C value is 1. Okay, now I could have done it the long way. And then combine the like terms, okay? Maybe need this? Okay, so we're going to graph each function using a graphing calculator. What do all the graphs have in common? Okay. If we graph these with the graphing calculator, it's going to take a little more time than if we don't, but let's see. And these are all going to be, if we plug them in, I'll go ahead and do a couple of them at least. Clear out what you already had in there. Okay, so it's 2x plus 1 times 2x minus 2. I'm going to go up to the first line, and you're going to have to put in the parentheses, just like it reads. Not the fastest at typing these in. Okay, so this is still a parabola. Okay. And the next line was 2x plus 1 times x plus, wait, no, it wasn't. I'm reading the wrong one. X plus 1 times x plus 1. And the last one, 2x. Is that a negative 2x plus 1, guys? Okay, just a bunch of parabolas, right? And they're shifted around a little bit. Okay, so these are all parabolas. You notice that when you multiply the first terms, this is the reason. This term is part of that FOILed out. X squared is a part of this one FOILed out, and 2x times 2x, 4x squared, that's part of that one FOILed out. So if you expand these all out, let's go ahead and finish it. The first one, we've got 4x squared. Next, we would have minus 4x. Then we'd have plus 2x. And last, we'd have minus 2. So that's going to be 4x squared minus 2x minus 2. The second one is going to be x squared times, now we got times x plus x, and then we have another x plus 1. So FOILed out, that's x squared plus 2x plus 1. And then the last one's going to start with negative 4x squared. But then we only have one more multiplication, so that's plus 2x. Okay, so that one has still got an x squared in it, but it does not have a third term because it wasn't a binomial times a binomial. And what we notice is all of these have an x squared in them, which makes them, the highest exponent for each of these functions is 2. It is called degree 2 polynomials. Degree 2 polynomials will be parabolas. We will be doing later different powers than this, but this whole unit is on degree 2. I may need that still? Okay. All right, so in general, a quadratic function is any function that can be written in the form y equals ax squared plus bx plus c. This is called standard form. Can you tell from the graph if it opens up or down? And that, I mean, from the equation of the graph, can you tell if it opens up or down? And it should be a yes. Okay, it's going to open if a is greater than 0, it's going to open up. If a is less than 0, it's going to open down, or if it's negative. So we're making some generalizations now. How can you tell from the equation of graph? We already said that. If f of x, the graph is a parabola, if it's in this format. If a is bigger than 0, the graph opens up, and the vertex is the minimum point. Minimum. The y-coordinate of the vertex is the minimum value of the function. If a is less than 0, then the graph opens down, and the vertex is a maximum point. The y-coordinate of the vertex is the maximum value of the function. That's the y-coordinate. Okay, so we got to talk about the axis of symmetry. What an axis of symmetry is, if you had a parabola and say it was over here. Now the axis of symmetry isn't the y-axis. You find the vertex and it would be this line right there. Sorry, mine's crooked. It's just how I drew. I didn't mean it to be slanted like that. This is your axis of symmetry. Okay, so if this was 1 and this was then a tick mark there 2, this would be the point, say the vertex was there at 2, 1. What would the axis of symmetry be? Well, it's the line through the vertex. I'm going to write through and not spell it actually correctly. Abbreviate it. Through the vertex, it is a vertical line. And it cuts the parabola in half. So you can say it just cuts in half. This line in this case would be the line x equals 2. That is your axis of symmetry, this line that cuts it in half. The definition of a vertex is the maximum or minimum point. Okay, now here is a recipe or formula, if you will, for finding the vertex of a graph. To find the x value or the axis of symmetry, okay, you're going to do the opposite of b over 2 times a. So how do you find the value of the vertex? So first of all, you take the equation, okay, and you find out to get the x equals, this is what you do. You find the x value, it finds you the x out value of the vertex. So if you know the vertex, you actually can tell what the x value is to find your vertex. This is going to be your axis of symmetry. Okay, it's the x value from the vertex. So now how do you find the y value of the vertex? Well, once you find the x value, you plug in the x value into the equation, back into the equation. Okay, so I'm going to do an example so you follow what I was just telling you. Somebody need this still? Because I wrote pretty fast. No? Okay, you guys are good. All right, what's a value on this equation? So a is a 1, b is a 1, c is a -6. To find the axis of symmetry, we do the opposite of b over 2 times a. So we're going to take the b value, which would be -1, over 2 times the a value, which is 1, which gives us -1/2. That means the axis of symmetry for this particular parabola would be x equals -1/2. It would be a vertical line at -1/2 that cuts the parabola in half. To find the vertex, the x part we already found, so it's -1/2. Now we need to find the y value. So we need to stick back in -1/2 into that equation. So y is going to equal -1/2 squared plus -1/2 minus 6. And you can calculate this with your calculator. -1/2 squared, if you want to change those to -0.5, that's fine with me. But this is, I'll do it without it. This is 1/4 plus -1/2 minus 6. You can type it like that on your calculator, or do 0.25 plus -0.5 minus 6. What is that? That's going to be -4.5 minus 6. So -6.5. This is only -0.5. This is what you would get. -6.25. You can convert that back to a improper fraction, which is -25/4. Some of them are icky. Worksheet 5 is where the assignment is. For those that are leaving early, you're going to try doing some graphs. We will continue some more tomorrow, so whatever you can figure out to do in that part section would be a good start. Number 7. See if we can't do at least a couple more here. Where is the vertex on this thing? So you go to the bottom. It's at -2, -3. Oopsie. Okay, -2, -3 is the vertex. You can just see it by looking. So the axis of symmetry is x equals -2. This parabola, of course, is opening up. You can see it. So it has a minimum. Okay, if you were to be able to write we're not doing this yet where you write the equation. This should have been taken off. We're not doing that yet. Okay, so where's the vertex on number 8? It's at 3, 4. So the axis of symmetry is x equals 3. It opens down, of course, so it has a max. Excuse me. Don't do the equation part. So what I want to get to is do a couple more of these before we go. So we've got the opposite of b over 2a. That is your recipe for finding the vertex. This one has an a value of 2, and there is a b value that's not there. Remember, it goes ax squared plus bx plus c. The b value, there's no x term, so b is 0, and c is negative 3. So the vertex will be the opposite of b, which would be opposite of 0 is 0, over 2a. 2 times 2, what are you going to get no matter what if the 0 is on top? Yep, 0. So 0 is your x value of your vertex. If you plug in 0, you get negative 3. The axis is x equals 0 for that parabola. The next one, a is a 3, b is a 6. We really don't need to write down c. Do you understand why? I don't really need the c value for the formula. So I'm just showing you a is 3, b is 6. The vertex then would be at the opposite of b, which would be negative 6 over 2 times a, 2 times 3. That's negative 6 over 6, which is negative 1. The axis then is x equals negative 1. You plug in negative 1 into the equation, and that's going to give you a positive 1 when you square it. So it's going to be 3 minus 6 minus 9. 3 minus 15 would be negative 12, right? Okay, so negative 1, negative 12. All right, that's about all we get to do today, and you're to be working on worksheet 5A. Have a great day. We will continue more notes tomorrow.